Hello, Algebra 2 students. This is a work of the Algebra 2 Chapter 7 test. So this is a practice, something you can view over and over again to determine if you are confident in your abilities to do these types of problems. So for the first problem here, we are doing we're doing operations with functions. So they're asking us to do four different things. The first one here is to subtract these two functions. So that means I'm going to add the opposite. So add the opposite of g of x. So I'm going to take f of x, which is 2x squared minus x plus 4, and then I'm going to subtract 2x and add 1. I'm adding the opposite of g of x. At that point, I just simply combine like terms. So I've got 2x squared. The minus x and the minus 2x are like terms. I can combine them. And then I have a positive 4 and a positive 1, which gives me a positive 5. Okay, so if I'm subtracting, I just add the opposite. If it would just be addition, you would just simply combine like terms. The next problem here is, bear with me here a second. Next problem here is multiplication. So when I am multiplying, because of the closed dot, I'm going to take 2x squared minus x plus 4. I'm going to multiply that by 2x minus 1. So here we're going to just distribute. I can do this in any order. What I'm going to do is I'm going to run everything through the 2x. So I would have 2x squared times 2x is 4x cubed. A minus x times 2x is a negative 2x squared, and 4 times 2x is 8x. And then run everything through the negative 1. So 2x squared times a negative 1 is a negative 2x squared. I'm placing it right here to keep those like terms together. Negative x times 1 is a positive x, and 4 times a negative 1 is a negative 4. Then I'm combining like terms, which is like adding functions. So I have 4x cubed minus 4x squared plus 9x minus 4. All right, then the next problem is to do composition of functions. This is an open dot. This means that I'm going to put f of x into g of x. F of x in for g of x, replacing the x. So I would have here 2 times f of x, which is 2x squared, minus x plus 4, and then I'm going to subtract 1. To simplify, I would just distribute this 2, so I'd have 4x squared. I'd have a minus 2x plus 8 minus 1, which comes out to be 4x squared minus 2x plus 7. All right. And then the last type of problem is composition of functions here. This is g of f of 3. So you do the inside parentheses first. We're going to find f of 3. Putting 3 in for f, that's going to be 2 times 3 squared minus 3 plus 4. Very important, you do the power first. So I have 3 squared here is 9 times 2 is 18. I can combine here, so this is 15 plus 4, which is 19. That's f of 3. That's the inside parentheses. So now I'm going to do g of 19, which means I'm taking 2 times 19, and I'm subtracting 1. 38 minus 1 is 37. Okay, the next type of problem here, to find the inverse of each function. If you're going to find the inverse of each function, you're going to use 2 steps. You are going to switch x and y, and and then you're going to solve for y. So in this first example, switch x and y, and then solving for y, I would add 3 to both sides, and then I would divide by 4. So that is the inverse of 4x minus 3 is x plus 3 divided by 4. On the other one, this is a quadratic equation, so I'm going to switch x and y. Solving for y, I'm going to subtract 1. I'm going to take the square root of both sides. So that's the square root of x minus 1. All right, now to graph these, going back to number 2, you're supposed to graph the function. So graphing this function, I would have 4x minus 3. So that is it's linear. My y-intercept is a negative 3. My slope is 4. I'm going to go up 4 and over 1. Up 4 and over 1. And this graph is a line. Okay. Then graphing the inverse, we can simply just switch these points. So I have 0, negative 3. My inverse would have to have negative 3, 0. I have the point 1, 1, so I need 1, 1. And I have the point 2, 5, so I need to have 5, 2. And then I draw my line. It should always be a reflection over the main diagonal, a function and its inverse. Okay. Another way to do this, if you look at the equation of the inverse, this equation is like 1/4 x plus 3/4. And if you look at the red graph we just drew, it does have a y-intercept of 3/4. We do go up 1 and over 4. The second one here, it's a quadratic equation, so we got to recognize that this is a quadratic. It's second degree, it's to the second power, so it is a parabola. This is a parabola moved up 1. So I move up 1, and then if you remember parabolas, we're going to go over 1, up 1, and over 1, up 3. And for this particular case, we should have said that x has to be just greater than or equal to 0. So I'm only going to deal with this side of the parabola. Okay, and then graphing its inverse, we can switch points. So in 0, 1, I'd have 1, 0. Instead of 1, 2, I have 2, 1. Instead of 2, 2, 5, I would have 5, 2. And my graph would look like this. That's the graph of this one, which remember is the square root function, and it's moved 1 to the right, which it actually is here. And it's reflected over this main diagonal.